I'm Subhashis Ghoshal. I'm a professor at the North Carolina State University and in the Stat Department. It's located in Raleigh, North Carolina in the United States. And I'm here for a program at the Newton Institute, and it's a long and complicated name representing, calibrating and leveraging prediction uncertainty from statistics to machine learning. In short, we call it RCL. So, one of the program organizers is Judith Russo. So, she and I know each other pretty well for at least 20 years, and we work on the same field. At least we have quite a bit of overlap in our work. So, she invited me to participate in the program and then suggested that given my profile, it may be possible to get a fellowship, one of the two fellowships, and she suggested that I go for it, and I really didn't have to do much. I just handed over my CV to them and they applied, and so all credit are theirs really. Yeah, my lecture is scheduled for August 5th, Tuesday at 4 o'clock. So, the title of the talk is Immersion Posterior, Meeting Frequentist Goals Under Structural Restrictions. So, this is about extending the one of the most important paradigms of statistical inference known as Bayesian inference. So, Bayesian inference goes like this: you start with some kind of initial assessment, which can be very vague. So, that is called the prior information, and you formulate that in terms of a probability distribution known as the prior distribution, and then you get the observation. You have a description of the mechanism, how they are related to unknown parameters, and by looking at the observations, you update your knowledge about the unknown parameters. So, this updated distribution is called the posterior distribution, and this procedure is done by a theorem from Thomas Bayes in the 18th century, that is called Bayes theorem. So, this is the posterior updating rule. So, in principle, it is a very transparent procedure. You have to start with some prior, and then you update your knowledge to a posterior distribution that is given by the Bayes theorem. But other than that, there are of course challenges in every step to implement this, and what is also transparency, and that is a real the big advantage and appeal, can also be a problem in some contexts because of the rigidity, because you cannot really maneuver it. It just you have to follow this once you choose the prior distribution. So, there have been sorts of modifications of the Bayesian paradigm to accommodate more flexibility. So, and my proposal would be to add another way of adding some flexibility, applying certain transformation on the output, so that we meet certain objectives. This is particularly important when we have some kind of structural restrictions in the parameters. So, for example, if the unknown quantity is a function and we have some additional information, say for example, it is increasing. Now, this is just a very simple example. Now, you can put a prior distribution to comply with that, but to put some kind of restriction like that, it also complicates the prior distribution in some way structurally, and the updating rule becomes far more complicated. So, if you can remove this restriction, typically this is easier, but of course, you have to come back to the restriction. So, what I am proposing is that you can do that at the final stage rather than at the initial stage, and if we do that, then it simplifies the procedure a whole lot of thing, and we can use much simpler prior. The updating rule becomes easier, the computation becomes easier, and most importantly what we are going to study here, how do they perform in terms of convergence, whether they are able to find the truth and at what speed. So, those kind of objectives we can meet more easily with this added flexibility. So, that is what I will try to explain, and with examples that how simpler this becomes when we add this flexibility to the Bayesian paradigm. This is a wonderful place to visit and work and interact with other people during our coffee time or during lunch, and this is away from other distractions typically from our everyday life. So, this is very enjoyable stay and very productive. I have been in at the Newton Institute before. I mean, I have been in Cambridge twice. One of those visits were to the Newton Institute, that was in August 2007. So, there was a conference on Bayesian nonparametrics, that is the primary research area I work on, and following the conference there was a extended program of 3 weeks, and I was on my first sabbatical at that time. So, I was participating in the conference. I gave one of the 4 tutorial lectures, and then this was later this tutorials converted to Cambridge book with chapters. One of the chapters I contributed, and then actually even more importantly, at that time I had a contract with Cambridge University Press to write a full text on Bayesian nonparametrics. So, we had this proposal submitted a year ago, and then it was already under contract, but exactly during this visit, I started actually writing the chapters. So, this was the first step towards that book, and from there it took about a decade, and finally it was published in 2017. And in another occasion I also visited, that was another conference was organized by Cambridge University, and it was just like 2 or 3 days conference. That's another time I came back to Cambridge, and I always enjoy my stay here. Very nice, beautiful.